From its name, gravity settlers rely on gravitational settling as a collection mechanism. It is also referred to as settling chambers, gravity collectors, expansion chambers, and outflow chambers. Settling chambers are generally built in the form of long, horizontal, rectangular chambers with an inlet at one end and an exit at the side or of the opposite end. Flow within the chamber must be uniform and without any macroscopic mixing. Uniform flow can be improved by employing flow straighteners at the inlet to the chamber. Hoppers are used to collect the settled out material, though drag scrapers and screw conveyors have also been employed. The dust removal system must be sealed to prevent air from leaking into the chamber, which causes turbulence, causes dust reentrainment, and prevents dust from being properly discharged from the device. This is our own model of a gravity settler used in air pollution. In most books, research, and video searches, gravity settlers are modeled for water treatments. The stringent control requirements adopted in the late 1960s through early 1970s have resulted in a sharp decline in the use of this type of collector. There are very few gravity settling chambers still in commercial use.
What we have here is a model of a gravity settler. Contaminated air enters the gas inlet, then the air is collected into this chamber and the dust particles along with the other pollutants exit through the dust hoppers. After which, clean air goes out through the gas outlet.
Gravity settlers are quite effective in removing only large particles. Thus, they are frequently used in combination with other control devices. This equipment is often used to reduce the inlet loading of particulate matter to downstream collection devices by removing larger, abrasive particles. Because of its usage, this type of air pollution control equipment is referred to as pre-cleaners. The efficiency of gas settlers increases with the residence time of the waste gas in the chamber. Because of this, settling chambers are often operated at the lowest possible gas velocity. In reality, the gas velocity must be below enough to prevent dust from becoming reentrained, but not so low that the chamber becomes unreasonably large. The most common failure of settling chambers is when chambers become plugged with collected dust. In expansion settling chambers, the plugging can result from the hopper bridging or hopper discharge seal failure. Gravity settlers offer many advantages. It is economic since it has a low capital cost and a very low energy cost, as well as low operating costs. Moreover, it has no moving parts and has excellent reliability. However, gravity settlers have relatively low particulate matter collection efficiencies and are physically large in size. It can't handle sticky or tacky materials. Furthermore, there is also the danger that the trays in multiple tray settling chamber may warp.